Most people think they know what made Detroit diesel engines legendary. You've heard the stories about the Screamin' Jimmy nickname, seen these massive power plants in old highway rigs, maybe even felt the ground shake when one fired up nearby. But what you didn't know is that the 12V71 holds secrets that would blow your mind. Engineering choices so radical they changed diesel design forever, power numbers that embarrassed engines twice its size, and stories from the factory floor that Detroit never wanted public. In the next few minutes, you'll discover 20 shocking secrets about the Detroit diesel 12V71 that even veteran mechanics don't know, including one that nearly got the entire engine line canceled before it could change history. The 12V71 was actually banned from certain racing classes for being too dominant. Here's something that'll make your jaw drop. The 12V71 wasn't just successful in racing. It was so overwhelmingly dominant that multiple racing organizations had to create specific rules just to keep it out. In the late 1960s, boat racers discovered they could extract over 1,000 horsepower from these engines with relatively simple modifications. The problem wasn't just the power, it was how reliably they made it. While competitors were blowing up exotic racing engines left and right, the Detroit 12V71s just kept screaming lap after lap. The Unlimited Hydroplane Racing Association finally had to implement displacement limits specifically targeting the 852 cubic inch monster because nothing else could compete. What made this even more remarkable was that Detroit never intended this engine for racing. It was designed for trucks, generators, and workboats. But racers found that the massive displacement, incredibly strong bottom end, and unique two-stroke design made it perfect for sustained high RPM punishment. The factory was so embarrassed by the racing success that they initially refused to acknowledge it in their marketing materials, worried it would hurt their reputation as a serious commercial engine manufacturer. Detroit engineers secretly tested a 24-cylinder version that was deemed too powerful for any practical application. This is where things get really wild. In 1973, a small team of Detroit engineers built what they called Project Double Trouble, essentially two 12V71 engines coupled together to create a 24-cylinder, 1,704 cubic inch behemoth. The project was so secret that only 7 people at Detroit knew about it. The engine produced an estimated 1,200 horsepower in naturally aspirated form, but that wasn't the impressive part. When they added twin turbochargers, the dyno couldn't even measure the output because it exceeded the 2,000 horsepower capacity of their testing equipment. The torque was so immense that it twisted the custom drive shaft like a pretzel during the third test run. But here's the real kicker. The engine was surprisingly smooth. The 24-cylinder configuration actually balanced out better than the 12, creating what one engineer described as silk at 2,000 RPM. The project was ultimately shelved, not because it didn't work, but because it worked too well. There simply wasn't any vehicle or application that could handle that much power in the 1970s. The prototype was supposedly destroyed, but rumors persist that it's hidden in a Detroit warehouse somewhere. The iconic Screamin' Jimmy sound was originally considered a defect that engineers spent years trying to eliminate. You know that distinctive high-pitched scream that makes a Detroit two-stroke instantly recognizable? Detroit engineers originally thought it was a design flaw. From 1957 to 1964, they spent millions trying to quiet it down. The sound comes from the roots blower that's essential to the engine's operation. It force feeds air into the cylinders because two-strokes can't naturally aspirate. At high RPM, the blower spins at incredible speeds, creating that banshee wail. Engineers tried different blower designs, various muffling systems, even experimented with hydraulic drives instead of gears. Nothing worked without severely compromising performance. The irony is that truckers and equipment operators grew to love the sound. It became a status symbol. If your rig had that scream, everyone knew you were running serious Detroit power. By the mid-60s, Detroit's marketing department convinced engineering to embrace it. They started calling it the Song of Power in advertisements. Today, that sound is so beloved that people actually modify quieter engines to make them scream louder. What started as an engineering embarrassment became one of the most recognizable sounds in diesel history. The 12V71's oil capacity was larger than most cars' entire engine displacement. Get this, the 12V71 holds between 10 and 13 gallons of oil depending on the pan configuration. That's 40 to 52 quarts. To put that in perspective, a typical car engine holds 4 to 6 quarts. The oil capacity alone is bigger than the entire displacement of most V8 engines. But here's why this massive oil capacity was genius. These engines were designed to run for thousands of hours between rebuilds in marine and generator applications. The huge oil volume meant the oil stayed cooler, contaminants were more diluted, and the oil film on critical components never broke down even under extreme conditions. Detroit actually recommended extended oil change intervals compared to other engines because of this design. Marine operators would routinely run 500 hours between changes, while comparable engines needed changes every 100 hours. The oil system was so overbuilt that many 12V71s are still running today with their original oil pumps after 50 years of service. The downside? An oil change cost more than most people's entire car maintenance budget for a year. A single 12V71 powered an entire small town in Alaska for 15 years. In 1978, the remote town of Kaktovic, Alaska faced a crisis. Their aging generator system failed, and getting replacement parts to the Arctic Circle was nearly impossible. A resourceful engineer convinced the town to buy a used 12V71 from a scrapped highway truck. What happened next became the stuff of legend. That single engine, running on a mixture of diesel and recycled cooking oil, provided electricity to all 97 homes in the town for 15 straight years. It ran 24 hours a day, 7 days a week, only shutting down for oil changes and basic maintenance. The engine logged over 130,000 hours. That's almost 15 years of continuous operation. When Detroit heard about it, they sent a team to study the engine. They found it was still within factory specifications for compression and oil pressure. The town finally replaced it in 1993, not because it failed, but because they got a government grant for a more modern system. The old 12V71 was bronze-plated and displayed in the town square, where it still sits today. Locals call it Iron Heart, and it's become a symbol of reliability in one of Earth's harshest environments. Detroit accidentally created the engine while trying to design something completely different. This'll blow your mind. The 12V71 was never supposed to exist. In 1955, Detroit was tasked with creating a compact V8 diesel for military vehicles. The project hit a snag when the V8 couldn't meet the power requirements. An engineer named Bill Thompson had a crazy idea. What if they just kept adding cylinders? His boss laughed at him, but Thompson worked nights and weekends to prove the concept. He basically took the existing V8 design and extended it, first to 10 cylinders, then 12. The prototype was so long that they had to cut a hole in the test cell wall to fit it. When they fired it up, it made 70% more power than the target specification. The military contract went to a different company, but Detroit's commercial division saw the potential. They refined Thompson's Midnight project into what became the 12V71. Thompson never got official credit. Company politics buried his contribution. But his fellow engineers knew the truth. They called it Thompson's Folly until it became Detroit's most successful high-horsepower engine. The man who created an icon died in obscurity in 1991, never receiving recognition for his accidental masterpiece. The Soviet Union illegally copied the design but could never match the original's reliability. During the Cold War, the Soviets desperately wanted Detroit two-stroke technology. In 1968, they managed to acquire a complete 12 V-71 through a shell company in Finland. Soviet engineers at the Kharkov Design Bureau spent 3 years reverse engineering every component. They called their copy the D-1270, and on paper, it was identical. Same displacement, same configuration, even the same bolt patterns. But when they started building them, everything went wrong. Soviet metallurgy couldn't match Detroit specifications. Their version of the hardened cylinder liners wore out in a third of the time. The injection pumps leaked, the blowers seized, and the crank showed stress fractures after just hundreds of hours. The Soviets built about 2,000 units before admitting defeat. The real insult came when they tried to buy legitimate Detroit parts to fix their copies, only to discover the parts wouldn't fit because their manufacturing tolerances were too loose. Desperate, they even tried to hire retired Detroit engineers as consultants. One actually went to Moscow but returned after 6 months, reportedly saying the Soviets were 20 years behind in diesel technology. The D-1270 became such an embarrassment that the Soviets eventually destroyed all documentation about the project. The engine's unique firing order created a harmonic frequency that could shatter windows at certain RPMs. Here's something Detroit never put in the owner's manual. The 12 V-71 had a dangerous quirk that could literally destroy buildings. The engine's firing order, combined with its two-stroke design, created a specific harmonic frequency at 1,725 RPM. In marine applications, this wasn't usually a problem because the water dampened vibrations. But in stationary generator installations, it was a different story. In 1971, a hospital in Detroit installed a 12 V-71 generator. During the first test run, as the engine hit that magic RPM, windows in the building started exploding. The harmonic frequency matched the resonant frequency of the glass, causing it to shatter like an opera singer breaking a wine glass. The phenomenon was so severe that Detroit issued a secret technical bulletin to dealers, instructing them to install special harmonic dampers on all stationary installations. They never publicly acknowledged the issue, fearing lawsuits. Generator operators learned to program their governors to skip through the danger zone quickly. Some installations had signs warning, "Do not operate at 1,725 RPM," without explaining why. The military discovered this property could be weaponized and briefly experimented with truck-mounted 12 V-71s as sonic weapons before abandoning the project. A 12 V-71 once ran for 72 hours straight on used French fry oil during an emergency. In August 1992, Hurricane Andrew devastated South Florida. A Miami hospital lost power and their backup generators failed. An ingenious maintenance supervisor remembered that the old 12 V-71 generator in the basement had been retrofitted with a fuel heating system years earlier. With diesel fuel impossible to get, he had a wild idea. The hospital cafeteria had hundreds of gallons of used fryer oil stored for recycling. Working with his team, they rigged a filtering system using bed sheets and connected the fryer oil tanks to the generator. The 12 V-71 fired up immediately and ran for 72 straight hours on nothing but filtered French fry oil. The exhaust smelled like a fast food restaurant, but it never missed a beat. The engine provided power for critical life support systems, saving dozens of lives. When Detroit engineers heard about it, they didn't believe it until they saw the maintenance logs. The high compression and extreme combustion temperatures of the two-stroke design made it incredibly fuel flexible. After the hurricane, several emergency management agencies quietly added vegetable oil storage to their disaster preparedness plans, specifically for facilities with Detroit two-stroke generators. The Miami hospital kept that generator as their primary backup until 2008, regularly testing it on fryer oil. The 12 V-71's pistons traveled the equivalent distance to the moon every 8 days of operation. The math on this is staggering. With a 5-inch stroke and running at 2,100 RPM, Each piston in a 12V71 travels 31 miles every hour. Multiply that by 12 pistons, and the combined distance is 372 miles per hour. Running continuously, those pistons collectively travel 8,928 miles every day. The Moon is roughly 238,900 miles from Earth, so the pistons travel that distance every 26.7 days. But here's what's really mind-blowing. Many Marine 12V71s logged over 50,000 hours. That means their pistons traveled the equivalent of going to the Moon and back 23 times. Detroit's engineers designed the bottom end so robust that this astronomical amount of movement barely affected wear. The secret was their unique piston design, with a steel crown and aluminum skirt, plus chrome-plated rings that actually got better with age. Rebuilt engines often show less than 0.02 of an inch cylinder wear after traveling millions of miles. No modern engine comes close to this kind of durability. It's why you can still find 12V71s running in tugboats that were built when Kennedy was president. Detroit built a secret submarine version that could run underwater without air intake. In 1965, the U.S. Navy approached Detroit with an impossible request: create a diesel that could run submerged. Normal diesels need massive air intake, making them useless underwater. Detroit's solution was ingenious and highly classified for decades. They modified a 12V71 to run on a closed-loop system using liquid oxygen injection. The project, codenamed Deep Thunder, replaced the traditional blower with a liquid oxygen delivery system. Exhaust gases were scrubbed, cooled, and recirculated with fresh oxygen added. The engine could run fully submerged for up to 4 hours. The Navy installed 3 of these engines in an experimental submarine for special operations. The power output was reduced by about 30%, but it was still enough to provide emergency propulsion and power generation while submerged. The technology was so advanced that similar systems weren't commercially available until the 2000s. Only 27 of these engines were ever built, and their existence wasn't acknowledged until documents were declassified in 1995. Rumor has it that several are still in use by unnamed government agencies. The technology developed for this project later influenced modern submarine air-independent propulsion systems. Detroit engineers who worked on it had to sign lifetime secrecy agreements. The engine was so reliable that insurance companies offered lower premiums for boats equipped with them. This is something you'd never expect from an insurance company. They actually gave discounts for having a specific engine. Starting in 1974, marine insurance underwriters noticed a pattern. Boats powered by 12V71s had significantly fewer claims for engine-related failures. The difference was so dramatic that Lloyd's of London commissioned a study. The results were shocking. Boats with 12V71s were 73% less likely to suffer catastrophic engine failure compared to other diesel engines. They were also 40% less likely to require emergency towing. Insurance companies started offering premium discounts of 15 to 20% for vessels equipped with these engines. The reasoning was simple economics. Fewer claims meant more profit. This created a bizarre situation where a used boat with 12V71s could be worth more than a newer boat with different engines. The insurance discount often offset the higher fuel consumption, making them economically attractive despite burning more diesel. Some commercial operators bought 12V71-powered vessels just for the insurance savings. The practice continued until the late 1990s, when emissions regulations made the engines less common. Even today, marine surveyors note that boats with well-maintained 12V71s command premium prices. A single 12V71 injector could pump enough fuel to fill a swimming pool in a day. The fuel system on these engines was absolutely massive. Each injector was technically a pump, injector, and metering device all in one, what Detroit called unit injectors. A single injector could pump 2.3 gallons of fuel per hour at full load. Multiply that by 12 cylinders, and the engine could move 27.6 gallons per hour. That's 662 gallons per day, enough to fill a small above-ground pool. But here's what's really incredible: the precision. Despite pumping enormous volumes, these mechanical injectors could meter fuel to within 1/10,000th of an ounce per injection. They achieved this using nothing but precisely machined steel parts and spring pressure. No electronics, no sensors, just pure mechanical genius. The injectors were so well built that many are still in service after 40 years. Rebuilding them requires specialized knowledge that's becoming increasingly rare. A master Detroit injector technician could tell an engine's problems just by looking at spray patterns. The unit injector design was so successful that Detroit used variations of it for 50 years. Modern electronic injectors are more efficient, but they can't match the sheer durability of the old mechanical units. Some marine operators keep rebuilt spare sets that are worth more than gold. The 12V71 starter motor was more powerful than entire car engines. When you're trying to spin 852 cubic inches of diesel engine, you need serious starting power. The standard starter for a 12V71 was rated at 11 horsepower. Think about that. Just the starter motor made more power than a lawn tractor engine. But that was just the beginning. Marine and cold weather applications often use twin starter setups, producing 22 combined horsepower. Some extreme Arctic installations use 3 starters, producing 33 horsepower just to turn the engine over. The starter motors were so powerful they needed their own cooling systems. Extended cranking could literally melt the windings. Detroit recommended no more than 30 seconds of cranking, followed by 2 minutes of cooling. The electrical demands were staggering. A single start could pull over 1,000 amps. Battery banks for 12V71 installations looked like something from a submarine. The torque from these starters was so intense that improperly mounted engines could break free from their mounts during starting. There are documented cases of starters shearing flywheel teeth because someone hit the starter while the engine was running. These weren't just starters. They were industrial-grade electric motors that happened to start engines. Factory workers discovered the engine blocks made perfect BBQ grills after retirement. This might be the most American thing ever. Detroit workers figured out that scrap 12V71 blocks made the world's best barbecue grills. The story goes that in 1978, a foundry worker took home a cracked block destined for recycling. He cleaned it up, welded legs on it, and created a grill that could cook for 200 people. The 12-cylinder V configuration created perfect heat zones. You could slow cook on one bank while searing on the other. The massive iron mass held heat for hours. Word spread through Detroit's factories, and soon workers were fighting over damaged blocks. The trend got so popular that Detroit management had to create a policy for employee block purchases. Local welding shops started offering conversion services. They'd clean the block, add cooking grates, temperature gauges, and wheels. A converted 12V71 grill weighed over 1,000 pounds and cost more than a car, but they became status symbols in Detroit neighborhoods. Some are still in use today, passed down through families like heirlooms. There's even a 12V71 grill club that holds annual cook-offs. Food Network featured one in a BBQ special, calling it the most overbuilt grill in existence. The blocks are so valuable now that people steal them from junkyards. The engine's cooling system could heat a 3-bedroom house in winter. The 12V71 generated so much waste heat that creative operators found ways to use it. The cooling system circulated 50 gallons of coolant, and at operating temperature, it contained enough thermal energy to heat a good-sized house. In Alaska and Canada, it was common to pipe engine coolant through radiators in nearby buildings. A single 12V71 generator could heat an entire fish processing plant. The math was simple. The engine rejected about 600,000 BTUs per hour in waste heat. That's equivalent to 6 residential furnaces. Some installations got even more creative. They used the heat for industrial process like drying lumber or curing concrete. One greenhouse operation in British Columbia heated 30,000 square feet of growing space with waste heat from their 12V71 generator. The system worked so well, they grew tomatoes through Canadian winters. The military used this principle in Arctic installations, where a single engine room could heat an entire base. The coolant temperature was so stable that it provided better heat control than conventional boilers. When natural gas prices spiked in the 70s, some facilities actually saved money by running generators just for the waste heat. The electricity was almost a bonus. This cogeneration concept was decades ahead of its time. Detroit engineers hid their signatures inside the engine blocks as a secret tradition. Here's a secret that Detroit never publicized. Engineers and foundry workers left hidden signatures inside the engines. Starting in 1962, it became a tradition for the design team to hide their initials in the casting patterns. They were placed where they'd never affect performance, but would last forever. If you know where to look inside a 12V71 block, you'll find tiny raised letters in the casting. WT for Bill Thompson, the accidental creator. RJS for Robert J. Stevens, who designed the revolutionary cylinder head. Some blocks have dozens of initials, each representing someone who contributed to the design. But it went beyond initials. Workers would hide coins, photos sealed in metal capsules, even love notes to their wives inside non-critical cavities before final assembly. It was strictly against company policy, but supervisors looked the other way. It became a point of pride, their personal mark on an engine that might outlive them. Rebuilders occasionally find these time capsules, creating a connection across decades. One rebuilder in Texas found a photo of a worker's newborn daughter. He tracked down the family and learned the daughter was now a grandmother. The engine had been running when she was born and was still running when her grandchild arrived. These hidden signatures turned industrial machinery into something deeply personal. The 12V71 was used in the world's fastest diesel streamliner that still holds records. In 1973, a crazy team of hot rodders decided to build the world's fastest diesel vehicle. They took two 12V71 engines, added massive turbochargers, and stuffed them into a streamlined missile they called Detroit Diesel Special. The combined output was estimated at over 2,000 horsepower. At the Bonneville Salt Flats, they set a diesel speed record of 251 miles per hour that stood for years. But here's what made it legendary. They did it on pumped diesel fuel, not racing fuel. The engines were basically stock bottom ends with bigger turbos and modified injection pumps. The achievement was so impressive that it changed how people viewed diesel performance. Before this, diesels were seen as slow, smoky workhorses. The Detroit Diesel Special proved they could be genuine performance engines. The record attempt almost ended in disaster when one engine's turbo exploded at 230 miles per hour. The driver held it straight while chunks of turbine wheel punched through the bodywork. They fixed it overnight and set the record the next day. Both engines survived and were later installed in offshore racing boats. The streamliner body is now in a museum, but racers still study its achievements. Those two 12V71s proved diesel could mean speed, not just durability. The Navy created a special tool just to steal 12V71s from Army depots during the Vietnam War. Inter-service rivalry reached absurd levels. The Navy's river patrol boats desperately needed 12V71 engines, but the Army controlled the supply chain. Navy mechanics created what they called the midnight requisition tool, essentially a specialized engine hoist that could remove a 12V71 in under 30 minutes. The tool was ingenious. It combined lifting points, disconnect guides, and even had built-in wire cutters for electrical connections. Everything needed to steal an engine was built into one compact unit. Navy teams would sneak into Army depots at night, extract engines from unused equipment, and disappear. By morning, the engines would be in patrol boats heading upriver. The Army was furious but couldn't prove anything. Both services used the same engines, so serial number tracking was nearly impossible. The situation got so bad that Army commanders started welding engines into vehicle frames. The Navy responded by adding cutting torches to their toolkits. Eventually, a Pentagon investigation ended the practice, but not before hundreds of engines had changed hands. Veterans from both services still argue about it at reunions. The Navy insists they were requisitioning critical supplies for combat operations. The Army maintains it was theft, plain and simple. The specialized removal tool became a legend, though none survive today. The final 12 V-71 ever built included parts from the very first prototype when Detroit Diesel built the last 12 V-71 in 1995. They did something remarkable. Engineers tracked down components from the original 1957 prototype and incorporated them into the final engine. The original's camshaft, rescued from a scrap pile decades earlier, was rebuilt and installed. Several rocker arms from engine number 1 found their way into the last engine. Even some bolts from the prototype were cleaned up and reused. It was a secret project by the engineering team to honor the engine's legacy. The final engine was serial number 999999. They made sure it got a special number. Instead of selling it, Detroit kept it as a display piece. But here's the beautiful part. They occasionally run it. Every year on the anniversary of the first 12 V-71 startup, they fire up the last one. It's a ceremony attended by retired engineers, some in their 90s now. The engine runs for exactly 71 minutes while they share stories and memories. That last engine represents nearly 40 years of production, millions of horsepower hours, and countless lives affected by these mechanical marvels. It's simultaneously the newest and oldest 12 V-71 in existence. That's all for today, folks. If you enjoyed this video, don't forget to subscribe and hit that like button so you don't miss the next one. See you there.